video, we learned how to find the derivatives of implicit functions. Let's consider this. If we have xy equals 1 and we want to find the derivative of y with respect to x in such function, we can differentiate both sides with respect to x. By the product rule, we take x, we differentiate y. In implicit differentiation, whenever we differentiate y, we multiply by the y dx. So the derivative of y with respect to x will be the y over the x. Plus, we take y, we differentiate x. We take y. When we differentiate x with respect to x, we have 1. And when we differentiate 1 with respect to x, we got 0. So clearly, the derivative of y with respect to x becomes negative y over x. Now, let's see how we can apply these to such function. If we look at the question on the board, it says, find the gradient of the curve x squared plus 3xy minus 5y plus y cubed equals 22 at a point 1, 3. If we take x squared plus 3xy minus 5y plus y cubed equals 22, we can differentiate through with respect to x. We differentiate x squared with respect to x. We differentiate 3xy with respect to x, negative 5y with respect to x, y cubed with respect to x, as well as 22 with respect to x. If we differentiate x squared with respect to x, we have 2x. This is a product rule. xy is a product rule. Remember, the product rule says if y is u times v, then the y dx will be you take one, you differentiate the other, plus you take the other, you differentiate the first one. So in this case, we take x, we differentiate y. We take x. When we differentiate y, remember y is an implicit function, so it's 1, we multiply by the y dx. Whenever we differentiate y, we add the y over the x. Plus, we take y, and we differentiate x. If we take y and we differentiate x, we get y times 1, because when we differentiate x with respect to x, we have 1. Minus, this is 5y. If we differentiate y, remember, it's an implicit function, so whenever we differentiate y, we multiply by the y dx. So it's 1 dy over the x. We differentiate y cubed. That will be 3y squared. One more time, it's y. So whenever we differentiate y, we have to multiply by the y dx. And this is equal to, we differentiate 22 with respect to x, that goes to 0. So we look for the gradient of the function, which is the y over the x. We can factorize the y over the x in this expression. If we factorize the y over the x, we will get 3x minus 5 plus 3y squared. And we can take 2x, 3y to the across the equal to sign. That becomes the negative of 2x plus 3y by grouping the like terms, all those with the y dx on one side and those without the y dx on the other side. So clearly, the gradient of the function dy over the x equals the negative of 2x plus 3y divided by 3x minus 5 plus 3y squared. This is the gradient of the tangent to the curve at any point. This is the gradient of the tangent to the curve at any point. So the question says, find the gradient of the curve at the point 1, 3. So clearly, at this point 1, 3, the value of x is 1 and the value of y is 3. So we can substitute x is equal to 1 and y equal to 3 into the gradient of the curve. That becomes 2, x is 1 plus 3, y is 3 divided by 3, x is 1 minus 5 plus 3, y is 3 squared. So of course, we can easily simplify. the numerator becomes, this is 2 plus 9, that is 11. And the denominator becomes 3 minus 5 is negative 2. And 9 times 3 is 27. So we got 2 plus 27, right? That becomes 25. So the gradient of the curve is negative 11 plus 25. All right, let's look at another example. If we consider this curve here, it said find the gradient of the curve at this point. If you want to find the gradient of the curve, find the gradient of the curve at the point where the curve crosses the x-axis. Now, we need to know the point first. At the point where the curve crosses the x-axis, y is 0. So when y is 0, clearly we got 2x cubed equals 16, and x becomes 2. So clearly, at the point where the curve crosses the y-axis, that point is the point 2, 0. So we look at the curve. We got 2x cubed minus 4xy plus y cubed equals 16. So we find the gradient of the curve. We differentiate through with respect to x. If we differentiate 2x cubed with respect to x, we got 6x squared minus 4. We differentiate xy. This is a product rule. One more time for product rule. You take the first, you differentiate the second, plus you take the second, you differentiate the first. So we take the first, which is x, we differentiate y. This is an implicit function. So when we differentiate y with respect to x, we got the y over the x. Plus we take y, we differentiate x. If we differentiate x with respect to x, we got 1. Plus we differentiate y cubed. That will be 3y squared. But remember, it is y. So in implicit differentiation, we have to multiply by the y dx. And when we differentiate 16 with respect to x, we got 0. So we can find the y dx in this. We group the like terms, all those with the y dx on one side and those without the y dx on the other side. So we can factorize the y dx out. And we're going to have negative 4x plus 3y squared equals, this is 6x squared. This is minus 4y goes there to become positive, right? Because this is negative, this is 6s squared across the equal to sign becomes negative 6s squared. Negative 4y across the equal to sign becomes positive 4y. So we can divide both sides by negative 4x plus 3y squared to get the gradient of the function of the curve over negative 4x plus 3y squared. This is the gradient of the curve at any point. At any point. But the question wants us to find the point where it crosses the x-axis. We already know that the point where it crosses the x-axis, y is 0. And when y is 0, we can solve this equation here. If y is 0, we can solve this equation here when y is 0 to get x is equal to 2. So we're looking for the gradient of the curve at the point 2, 0. This means x is 2, y is 0. So y is 0, x is 2. So this is 4 times negative 6. That is negative 24 over negative 8. Of course, we can simplify. We know negative 24 divided by 8. We know the value. So that becomes the gradient of the curve. Now, let's look at one more example, which is a bit involving. So if we look at this curve here, it said the equation of a curve, let me take out this one first. If you look at the example on the board, It says the equation of a curve is 5x squared plus 2xy plus 2y squared equals 45. Given that there are 2 points on the curve where the tangent is parallel to the x-axis, show by differentiation that at this point y equals negative 5x. And the second part, find the coordinates of these 2 points. All right, so this is basically simple. If we take the curve 5x squared plus 2xy plus 2y squared equals 45, we need to look at the point where the tangent is parallel to the x-axis. Now, we know that a tangent is a straight line, and every straight line is of the form y equals mx plus c. So any line which is parallel to the x-axis is of the form y equals c. That means the gradient is 0. So any line parallel to the x-axis has a gradient of 0. In other words, if the tangent to this curve is parallel to the x-axis, then the gradient function of the tangent must be 0. So we differentiate and equate it to 0. The same approach we differentiate throughout with respect to x. If we differentiate 5x squared with respect to x, that gives us 10x. Plus, this is a product rule. So we take x, we differentiate y, plus we take y, we differentiate x. We take x, we differentiate y, that will be 1. But remember, we are differentiating y with respect to x. So as an implicit function, it becomes 1 multiplied by dy dx. Plus we take y, we differentiate x, that becomes 1. If we differentiate 2y squared, that becomes 4y dy over dx, of course, because this is an implicit function. And when we differentiate 45 with respect to x, that gives us 0. Now, we find dy dx in this expression. Of course, when we make dy dx the subject of this expression, we have negative 10x plus 2y divided by 2x plus 4y. Now, remember, as we said before, the gradient of if the tangent is parallel to the x-axis, then the gradient function must be 0. So we have the expression negative 10x plus 2y over 2x plus 4y must be 0 because the tangent to this curve is parallel to the x-axis, so the gradient is 0. So if we divide two numbers and we get 0, if we divide two numbers and we get 0, it means one of the numbers must be 0. So in this case, we know that b can never be 0 because it's a denominator. So only the numerator can be 0. So only the top part, which is the negative of 10x plus 2y, can be 0. And clearly, y equals negative 5x. So we show from this equation that y equals negative 5x. The question says, given that there are 2 points on the curve where the tangent is parallel to the x-axis, show by differentiation that at this point y equals negative 5x. So y equals negative 5x at the point where the tangent is parallel to the x-axis. Let's look at the second point. Hence, find the coordinate of these 2 points. Remember, at the point where the tangent is parallel to the x-axis, y is negative 5x. And this is the equation of the curve. So we can solve the equation of the curve and the equation y equals 5x to find these 2 points. So we are solving these 2 equations as equation 1 and equation 2. Of course, we can solve by substitution method by substituting y equals negative 5x into equation 1. So if we substitute y equals negative 5x, we got 5x squared plus 2x. Wherever we see y, we substitute negative 5x plus 2. Whenever we see y, we substitute negative 5x. And this is 45. So we can simplify and solve for x. So this is 5x squared. This is 25x squared times 2, 50x squared. So we got 5x squared minus 10x squared plus 50x squared being equal 45. So 5x squared minus 10x squared plus 50x squared becomes 45. X squared equals 45. So clearly x will be plus or minus 1. And remember, y equals negative 5x. So y will be minus plus 5. Because when x is positive 1, y is negative 5. And when x is negative 1, y is positive 5. So the 2 points are when x is positive 1, y will be negative 5. And when x is negative 1, y will be positive 5. So these are the 2 points. So this is the end of our class. If you are interested in this video, please subscribe to my channel and see you in the next video.